Implicit differentiation. So implicit differentiation involves taking the derivative of functions that contain different exponent values of y, such as y squared or y to the power of 3. And so far we've only seen to y to the power of 1. So these new functions don't fit our typical formulas because they don't even pass the vertical line test. So they're not even actually a function. They have multiple values of y for a single value of x. In order to determine the derivative of these types of functions, we're still going to use the same derivative rules, but the key idea is that we're going to treat y as a function of x when we take its derivative, and you'll see what I mean in a minute. Then we're going to rearrange the derivative and solve for y. So let's take a look at an example. We've got x squared plus y squared equals 9, and this is a circle. So we're going to take the derivative in relation to x. Depending on the function, you'll see that there's different rules that we're going to apply, but they're all the same rules we already know. So first we're going to take the derivative of x squared, and then we're going to take the derivative of y in relation to x, and we're going to take the derivative of 9 in relation to x. Derivative of x squared is just 2x. Derivative of y squared, well, y is a function of x, so it's going to be 2y. We keep the same function, and then we don't actually know what y, the derivative of y is, so we have to just leave it as the derivative of y, and then 0. Now when we rearrange this, we have 2y times the derivative of y minus 2x, and we can see that the derivative of y is actually, sorry about that, and that should be is actually just negative x over y. And now we have to evaluate it at this point, so we're just going to plug that into here. And the derivative of y at that point is just negative 2 over root 5. Let's try another example. Okay, so we're going to take the derivative of this guy in relation to x. So the derivative of the first part in relation to x is 4 times 3x squared. The derivative of the second part is going to be 3y squared, and then the derivative of y, which is unknown at this point. And now we're going to rearrange. Actually, let's just simplify it first. 12x squared plus 3y squared, derivative of y equals 0. All divided by 3y squared. Simplify that further, negative 4x squared over y squared. We have this point that we want to evaluate it at. And so we're going to plug that point value into this expression. This is negative 4 over 9, and that's my slope. And now I can use whatever strategy I want to find the equation of the line. So I can go, or I could use, let's use this one this time. So my point form, and my point is negative 1 plus 3. Okay, let's try one more together, and then you guys can do some homework. Okay, so I want to find y primed, so I'm going to take the derivative of both of these. Now I have the product rule here, so I'm going to have to take the derivative of the first, keep the second. Keep the first, take the derivative of the second, and throw in my y prime there because I don't know what it is. And I have 1/2 y to the negative 1/2 and y primed equals 0. Okay, so now I have two y primes, and so I'm going to have to deal with that a little bit differently. So the first thing I'm going to do is I'm going to actually move this guy to the other side of my equation, get him out of the way, negative 2xy cubed. And now, after I've done that, now I actually have a common factor of y prime. So I'm going to common factor it out. That leaves me with x squared 3y squared plus 1 over 2 root y. Now I can rearrange to isolate y primed, negative 2xy cubed on top, all over, let's rewrite this, that is a little bit cleaner, x squared y squared plus 1 over 2 root y. So give these a try in the text, page 107, numbers 1, 2, 3, and 5.